So today we will learn about application of sequences in series. And first we'll do one famous example. Open your booklet on the page 17, example 4. Example 17, so example 4, page 17. I think you all heard about this legend that there are a few different versions of this legend. In this one, the king of Persia offered some mathematician Sanadu, I'm not sure how to pronounce it, some reward. And Sanadu did what king asked him, but requested as a reward chessboard with 1 grain of rice on the first square, 2 grains on the second, 4 on the third, and so on until all 64 squares will be filled with rice. And the legend, king was, why are you asking so small reward? And asked his other mathematician to calculate how much rice needed. You all probably heard this legend. Yes. Yeah. And then they were counting the whole night, and they came in the morning and said there is no such rice in the whole world. Question is, determine total number of grains of rice they needed to supply. So first, we need to realize what kind of sequence it is. A geometric sequence, because with the A, first term equals 1, and common ratio equals 2. And what we need to find?
64.
Sum of 64 terms. So we need to find S 64. Lucky we know the formula for the geometric series, for the sum of n terms of geometric series, which is Sn equals a I in the power of n minus 1 divided by r minus 1 equal 1 times 2 in the power 64, S64, 2 in the power 64 minus 1 divided by 2 minus 1, and this number is 1.84 times 10 in the 19 grains of rice. Shows not the whole world does not produce that much rice. But B asked weight. If 1 grain weight 0.1 gram, how many kilograms of rice this represent? So we divide this by we multiply it by 0.1, and it will be 1.84 times 10 in the power 15 kilograms. That's a lot. That's a lot.
Wow.
So that's just one application of the geometric sequence. Another one of the real-life applications of the geometric sequence you will be facing many times in your life, because it's related to the finance. When you will be borrowing money from the bank, or you will make some deposit in the bank, how calculations are done. Because there are 2 types of interest. I hope you remember from the like junior years, what two types of interest?
Compounding.
Compound and
Simple.
simple.
Yes.
No, in reality, banks using compound interest.
Yes.
What does it mean, compound interest?
It means that it just goes on itself.
Yeah.
Like
The interest is calculated on the interest.
yeah.
Interest calculated on the interest. So, the formula for if, let's say, you deposited P, that's principal, you deposited that much money in the bank, and the interest rate is R, percentage per annum. In reality, even if the interest rate per annum calculations done, interest calculated daily and compounded monthly, usually in the most cases. And you deposit it for n years. So how much money will you get at the end? How much money you will get at the end? So we have, so that will be again geometric series, and we get that amount will be equal principal times 1 plus R over 100, because it's in the percentage when you turn to the decimals, in the power of n. That's how money will be calculated. That is simple example when you don't withdraw, you don't add money to the account, so this will be pretty simple example. The same thing is similar way, such thing as depreciation counted. You know what the depreciation is?
Yeah.
Yeah, that's when you buy something over the time, its value usually declines, and then the difference will be, that amount will be equal when the depreciation, original amount times 1 minus R over 100 in the power of n. So this is pretty simple calculation, but in reality, let's say when you take a loan, you make repayments. How we do calculation in this case? How we do calculations when you make repayments? So let's consider and let's make the table. First, recurrence table. I guarantee there will be question on the SAC where we will need to produce recurrence table. So let's say you have borrowed to buy your first car. You have borrowed $20,000, and you've been lucky and got interest rate 8% per annum, which in the current time you will be really lucky if you will be able to get such interest rate on your loan, when you get a car loan. But it's possible, but it's usually high. And you make, and that will be compounded annually, so in reality it will be monthly, but to make calculations more simple, we'll do it annually. And you make in repayments $2,500 per year. That's what you do repayments. So let's make the so-called amortization table, where we have payment number, payment, interest, principal reduction. Principal is how much you borrowed. Principal reduction. And balance. And we start from payment number 0, when you have not made any payments yet. 0, no interest calculated, no principal reduction. Your balance is 20,000. So that's what you borrowed. After the 1 year, how much interest will be calculated? Calculate 20,000, 8%, 1,600. So interest is 1,600. You make payment 2,000, payment number 1, $2,500. So what will be now how we find balance?
Payment minus.
We do to 20,000, we plus interest and minus how much repayment you make. So that will be 19,100. By how much principal reduced? 900. So you see, you pay 2,500, but only your principal, how much you owe, reduced by just 900. Payment 2. Do calculations and tell me what will be, but interest now will be calculated on this balance, not on 20,000. You use calculator, you can use calculator.
382 minus.
15, wait.
28.
382 minus
1528, yes. 1528. Payment still 2,500. So balance you add interest and subtract repayment. And subtract repayment, so you get $18,128, and principal reduced now by 972. And we'll do one more. Third year, payment 2,500. Calculating interest on 18,128 will be $1,450.24. So balance will be $17,078.24, and principal reduction is $1,049.76. So over 3 years of such loan, you paid 7,500 to the bank, but your loan reduced less than by 3,000. Yeah. So that's how the compound interest works. And does everyone understand how to make amortization table?
Yeah.
Because yeah,
So there's a lesson to buy a used car.
Hmm?
There's a lesson to buy a used car.
Buy used car?
Well,
What?
you make it look pretty grim.
7,500.
Yeah, but-
We can live in public houses.
But I will say most realistically, it will be not 8%. It will be more realistically will be about 12-14%.
I don't know.
I think I will only buying a house in the next century.
It's complicated.
And so, for example, when you get a mortgage, you buy your house, and per month you will see like you pay per month, for example, like 3,000, repayment to a bank per month, and your mortgage will decrease like by $100.
Oh, that's not good.
It's not good, yes. So, just note about Lithuania a little bit. So, it is usually,
20 years on
it can be a good idea. No, usually it's usually 30 years loans, common. It will be a good idea to have so-called offset account.
Oh, yeah.
When you have, let's say you borrowed $900,000 to purchase a home, and you have, let's say you have $10,000. If you put them on into the offset account, then the interest will be calculated not on 900,000 by 900,000 minus this 10,000 which are in your offset account. So it will not make big difference, but still make difference, and this difference will be accumulating over the time. So it's more money you will have.
Withdraw from an offset account.
Yes. You can you can make it depends different banks with different conditions, but generally saying if you have offset account that you can use as your like everyday account, that will help to pay down mortgage faster. So that will be my advice for the future when you get to that. So that's how to do amortization table. Now another one more example for the geometric sequence, then we look into the combined sequence. So geometric and arithmetic sequence combined together. So in your booklet, on the page 16, on the page 16, there is an example 3. Page 16, example 3. So we have logs of wood can be stacked so that there is one more log on each descending layer that on the previous layer. The top row has 6 logs. So next layer can have one more. So there will be 1, 2, 3, 4, 5, 6, 7 logs. And there are 20 layers. Question is, how many logs are there? What kind of sequence is this? Arithmetic. This is arithmetic. We're not multiplying, we're adding common difference. So what we have, what is our A? 6. What is our common difference? 1. And we need to find sum of the first 20 rows. Using formula for arithmetic sequence, we have 20 n on 2 times 2 times A, so 2 times 6, plus 20 minus 1 times 1, because the common difference is 1. Calculating this will get 310 equal 310 logs. So in 20 rows will be 310 logs. Make sense?
Is it 20 minus 1 because D is 1, or is it always 20 minus 1?
Because D is 1.
So the -1 and the times 1 is both D.
Sorry, no. This one is D, this is D, and this is n minus 1.
Yeah.
Because from first to the 20th we have 20 minus 1, 19 steps. So yeah, this is n minus 1, this is D. And this is 2 times A, and this is n. And this is n. But be more interesting, logs to be separated in 2 equal piles. Starting removing logs from the top of the pile. How many rows will be taken away before there will be half left? So how many logs should left? 155. So what equation we can make? We can calculate how many, counting from the top, how many layers will give 155 logs. So using the formula, 155 is S of unknown number, so we have n on 2 times 2 times 6, the A is 6, plus n minus 1 times 1. Does it make sense how we made this equation?
Yeah.
And expanding, like collecting like terms, we will get to the equation that n times n plus 11 on 2 equals 155. Rearranging it, we get quadratic equation. N squared plus 11n minus 310 equals 0. And those numbers you cannot factorize it. Oh no, you can use in the completing the square, but it's easier to use quadratics formula. So if you use quadratics formula, you will get n equals 12.95 plus another number which will be negative, which we reject. We cannot have negative number of the rows. So therefore, how many rows should be removed? No, it will be more than a half. 12 rows and because we need to make exactly 155.
So we have
0.995% of, sorry, if you calculate 12 rows, how many it will be? If you calculate S12, S12. Calculate, can you calculate what will be S12 equal? Now using the formula,
yeah.
you have S12, because you're removing 12 will be 12 divided by 2 times 6 plus 12 minus 1 times 1.
138.
100? Sorry, 100?
And
30.
30. 138.
138? So we removed 138. We need to remove 155. So how many logs we need to remove from the 13th row? 17. 155 minus 138, so 12 rows plus 17 logs from the 13th row. Make sense how we solve this problem?
Yeah.
Okay. Now, yes, Ellie, I can see question in your eyes. Okay. Then let's consider combination sequence. if we have sequence of the type Wait 1 second. Yeah. If we have recurrence relation of the form Tn equals R times Tn minus 1 plus D. So as you can see, it's kind of combination of geometric and arithmetic sequence, because we multiply in previous term by you cannot say exactly common ratio, because it will not be ratio of two consecutive, but multiplying by the same number and adding the same number all the time. So how we can approach this kind of sequence? How we can approach this kind of sequence? So, if we write few more terms, so Tn minus 1 will be equal R times Tn minus 2 plus D. Tn minus 2 equals R Tn minus 3 plus D. But and we get into the very first one, so T2 equal R T1 plus D. Now let's multiply each of those equations by R in the power, this by I in the power 1, this by power R in the power of 2, and so on. Why are we doing that? If we do what, we will achieve. What we will achieve in terms of the power of R. Okay, let's start. Let's say T2 equal T1R plus D. So we multiply this by R. So we get RT2 equal T1R squared plus DR. Right? T3 equal T2R plus D. Multiply this, we need multiply by we need to multiply by R squared. So we get R squared. And if we substitute here, this one instead of T2,
we're just going to get T, the same as on the right.
we will be only like T1. And if
Yeah,
you
but it's just the same as on the right.
hmm?
If you sub it in, it's just.
That will be the same thing. So if we will add all those equations after multiplication, we will get Tn, will be equal R n minus 1 times T1 plus D times R in the power n minus 1 over R minus 1. No, sorry. I combined two steps together. So we get T1 times Rn minus 1 plus D plus Rd plus R squared D and so on, which combining all those will give us formula Tn equal Rn minus 1 T1 plus D Rn minus 1 over R minus 1. This is the formula for calculating nth term of such combined sequence. So let's consider question. If we have the next recurrence relation, Tn equal to Tn minus 1 plus 1 and T1 equals 10. What will be the formula for the nth term? Tn equal, what I equal? 2. And so we have 2 in the power n minus 1 times T1, which is times 10, plus what D equals?
1.
D equals 1. 1 times R, 2 in the power n minus 1 over 2 minus 1 over 1. Let's simplify it. We get 10 times 2n minus 1 plus 2n minus 1 minus 1. So we get 11 times 2 in n minus 1 minus 1. Okay. Makes sense how we got the formula for nth term. Now try to do, if we have, let's say R equals 1/2, D equals 8, and T1 and T1 equals 5. Try to get formula for Tn. Substituting numbers into that formula. So we have formula for nth term. We have R, we have D, and we have T1. Do a little bit of algebra. this takes so long?
No, it's 5 over 2 to the n minus 1 plus 16 times 1 minus 1 over 2 to the
And you can,
minus 1.
if you combine, simplify it further,
Then
it becomes Tn
equals
16,
5 plus 16, 2 to the n minus 1.
16 minus 11
Yeah.
divided by 2 in n minus 1.
Yeah.
That's what you will get in this formula. If you do like algebra correctly. And let's do one example, and then you can start trying by yourself. And that will be example from the textbook. Example that will be question from exercise 3G. Question question 11. Yep. So we have, because this is more difficult question, this question 11. Because we adding now, we will be adding not the same number. So d now not constant. D will be function. Now what we adding, we still multiplying by the same number, but what we adding function. So we get
Mr. B, where are these questions?
In the text.
this one, this particular example that I will be doing in the textbook. And exercise 3G, question 11. So we have recurrence relation Tn equal Tn minus 1 plus 2n. No, easier part that I equals 1. But we have now the adding function, in this case 2n. And derive formula for Tn. Not as a recurrence, but as a formula. And the easiest way to do it, to use a method that I've explained you when we were starting topic sequences. So let's find few first terms. Let's find few first terms. If we take n, and we need Tn minus 1, T1 equals 5. T1 equals 5. So we have T1 equals 5. What will be T2 equals?
T2 equals 5 plus 2.
Yeah, so what the number?
Nine.
N equals 2,
9.
9. T3, n equals 3,
Yeah.
will be 15. T4,
93.
Will be 23. And one more, T5, we actually don't need that many, but let's do one more. 33, yes. Does everyone understand how we get those numbers? We're substituting and in this formula. So what we should do now? Find difference between them. 4, 6, 8, 10. Not the same number. Let's subtract again. 2, 2, 2. On which step we got same number?
Third.
Second.
Ah,
Second. This is not a difference, this is the actual
Ah.
numbers. So what will be? We'll have quadratic. So the equation for this sequence will be quadratic because we get same difference on the second step of differences. So we will have the Tn will be equal n squared, an squared plus bn plus c. Plus c. And let's substitute. We have now the T1, T2, T3, we need three equations because we have A, B, and C. So we have n equals 1, we have 5 equal A plus B plus C. N equals 2. N equals 2, we get 9, because second is 9, equal 4A plus 2B plus C. And what will be the third equation?
15 equals 9A plus 3B plus C.
We have 9A plus 3B plus C. What will be the easiest way to solve those simultaneous equations?
Well, you can get rid of C pretty quickly.
Yes, so let's subtract this,
From this.
do the equation 1, 2, 3. Let's do 3 minus 2.
And then
3 minus 2, we get 6 equal 5A plus B.
And now 2 minus 1 as well.
Now we do 2 minus 1, we'll get 4 equals 3A plus B. If we do 2 minus 1, 4 equals 3A plus B. Now, if we subtract equation 4 minus equation 5, why we will subtract it? We get rid of B, we get A straight away. So we subtract, we get 2 equals 2A. So A equals 1. Substituting it back, so we get 4 equals 3 plus B, B equals 1. Substituting back into, let's say, first one, what C equals? C equals 3. So the equation will be n squared plus n plus 3. Double checking that we have not stuffed up calculations. I already lost it. Maybe. Here we get n squared plus n plus 3. Make sense? How we did it. Okay, that's all for today. Like, subscribe, and donate to help fight terrorist countries and organizations. Slava Ukraini, and Mr. Khai.